Hello guys, welcome to Yebo Tutor Livestream Help. I hope you are all good. It's been quite some time, but I'm happy to be here guys today, streaming live from Nelson Mandela University. Come on in, come on in. Share with friends, share with friends. Let's see, who do we have inside? Who do we have inside? I can see we have Kanye. Let's get to business. Yes, let's get to the business of today. Let's see what we have today. It's a calm weather in Gqeberha. It's quite great. Lord help us. So today we'll be doing a control test for this year. It's leaked, guys. Share with friends that we have a new control test for this year. It has been linked already. Come on in, come on in, come on in. Let's get down to the business of the day. So if you are a returning subscriber, please don't forget to continue sharing and continue watching us live. That's amazing, so that at least you can get information and also share with friends and family. We are here guys so that we can empower each other. All right, and if it's your first time to watch us, don't forget to subscribe, don't forget to comment and like so that we can continue producing good content for you guys. So without wasting much time, let's get down to the business of the day. Kanye, are you ready? Can you just type something in the group, on in the chat? You can type us on the WhatsApp group as well, guys, so that at least we can be able to interact together. Okay, just type something. I'm also on on our WhatsApp group, so if you have a question, just type on the WhatsApp group as well, so that we can be able to interact together. Let's get to it. Let's get to it. Let's get to it. Let's give maybe 2 minutes so that you can see if we are with some friends with us. Okay, let's go. Now, question one. This is leaked, guys. Share with friends. This is leaked. This is leaked. This is the paper for this control test for the term one. So for now, we have already covered number patterns. We also did Euclidean geometry. I think it's last week or last week. It was great. We covered everything. We focused on prop theorem. We looked at the similarity theorem. We also did a tutorial. We did questions on those specific things. How do we reason? Now let's try to attempt a control test for term one. So guys, what is important is to understand that each and everything you did the past weeks is now contributing for us to understand or to apply it when we're writing our control test right now. So if you have any question, type on the WhatsApp group. You can also type on the comment section. It's there right now with us. Let's go guys. So as you can see, this is our control test for term one. It consists of 6 pages, instruction and information. Always read your instructions so that you don't answer wrongly. Answers only will not necessarily be awarded full marks. If necessary, round off to 2 decimal places. So this is so important for you to understand that in everything you do, if it's necessary, just round off to 2 decimal places if it's not been specifically said so in that specific question. Now let's look at question number one. Let's go. Consider the quadratic number pattern which we are given here. Let's go. So question 1. I love black. Also, when you're writing, guys, please use a black pen. Okay, question 1. So on question number 1, what is it saying? Let's go. Consider the quadratic number pattern. Consider the quadratic number pattern, which is negative 1 over 2. We are also given 2. We are given 11 over 2. We also have 10. Okay, so what are we given? It's a quadratic number pattern. What do we remember about a quadratic number pattern? We remember that it has a second constant difference. So since it has a second constant difference, which means that the first difference of a quadratic number pattern is an arithmetic sequence. So now we were able to analyze what we are given on the statement which says consider. Now we want to apply it. Now we can answer the question. Now write down the value of T5, which is the term number 5. Let's first determine the second difference first. So how do we do that? As always, 2 minus negative 1 over 2. What's going to be our answer if we subtract them? So when we are using our Casio calculator, guys, always when you're going to the exam, use your Casio calculator. This is so important. This is so crucial in assisting you not to waste time trying to subtract things which are already obvious. So using our Casio calculator, 2 minus 1 over 2, it's 5 over 2. Then 11 over 2 minus 2, that should be 11 over 2 minus 2. Then we have 7 over 2. Then 10 minus 11 over 2. 10 minus 11 over 2. Then we get 9 over 2. Okay, guys, why is Vuyani using the calculator in front of you guys? I want you guys to know that in each and everything you are doing now at this stage, you don't have to use your mind. Just use your calculator because you only have stipulated time, which is so small. So use that time wisely. So in all questions, just use your calculator to prevent you doing mistakes, prevent you from doing anything. Use your Casio calculator. Okay, now 7 over 2 minus 5 over 2, then that will be that should be 1. Then 9 over 2 minus 7 over 2, that also 1. Then now we know our second constant difference is 1. Okay, so our D is equal to 1. But this is not what we asked. So in 1.1, they want the term number 5. 1, 2, 3, 4. So how can we get term number 5, guys? How can we get term number 5? How can we get term number 5? That's what's important now. How can we get term number 5, guys? Let me see something. There's a technical glitch. Let me fix that fast. Let me fix that part. Hi guys, I'm so sorry for that technical glitch. It was just a small glitch which just happened, but now everything is fixed. So now we say that our constant difference is 1. So on the comment section, I'm seeing Kanye, he is saying, please try getting the Northwest one. Okay, we'll do that on Friday. We'll do another one from Northwest on Friday so that at least we can keep in touch with everything. No, thank you so much, Kanye. You are noted. So after that, now we know our common difference. Now they want T5. How can we find T5? That's easy because now we know that this is T number 5 and we know that the difference is always constant. So we're going to say 9 over 2 plus 1. 9 over 2 plus 1. Then we should get 11 over 2. So here it's 11 over 2. Then now 10 plus 11 over 2. 10 plus 11 over 2. Then we get 31 over 2. So what is our T5? Our T5 is 31 over 2. This is easy. So how do you manage to see that? So when we were finding the first difference, the second difference, we were subtracting T2 minus T1. So now if we want the next following term, we start from the constant difference, which we now know that it's 1. So the common difference, which is equal to 1, is going to build us to find the T5. So 9 over 2 here plus 1, we get 11 over 2 here. So when we say 11 over 2 minus 9 over 2, we still get that 1 here. Okay, now in order for us to get 31 over 2, we say 10 plus 11 over 2, then we get 31 over 2. So when you're going forward, you add. When you're going backwards, you subtract. That's easy as that. Forward add, backwards we subtract. Then now we have our T number 5. Now let's proceed, let's proceed, let's proceed. Let's see what we have, guys. Let's see what we have here. Okay, now we need to determine, show the general term of the pattern. What is the general term of this pattern, guys? This is easy. This is really, really easy, guys, because now we know how to determine the we know how to determine the what do we call this? We know how to determine the a general term of a quadratic number pattern. How do we do that, guys? How do we do that? So we know that the quadratic number pattern has this amazing, let me call it amazing, yes, this amazing uh general term. How do we find it? So we know that the general term is found by saying 1.2 Tn is equal to an squared plus bn plus c. What is a value of a, what is the value of b, what is the value of c? So this is what is important. So the value of a, we find it by saying 2a is equal to d, where d is the constant difference, okay? And the constant difference in this case was 1. So 2a is equal to 1, then a will be equal to 1 over 2 because you make a the subject of the formula. Now we want the value of b, and we know that in order for us to get the value of b, we say 3a plus b is equal to t2 minus t1. What is our a? Our a, we have calculated it, it's 1 over 2 plus b is equal to t2 minus t1 is 5 over 2. So now we have our 5 over 2 here. Then b will be equal to 5 over 2 minus 3 over 2. Then what is our value for b? It's going to be equal to 1. This is easy. As we said, guys, we are using our Casio calculator. Then now we want the value of c. A plus b plus c is equal to t1. What is our value of a? Our value of a was 1 over 2. Our value of b was 1. Then we are looking for c. Then what was our t1? Our t1 was negative 1 over 2. Now this is easy because we know that this is negative 1 over 2. So 1 over 2 plus 1 plus c is equal to this. So definitely we should transpose these values. Then we get c to be equal to, so we say it's going to be negative 1 over 2 minus 1 over 2 minus 1. Then we get our answer to be negative 2. So then therefore, you're not done by just having these values. Write it as a general formula. Therefore, Tn is equal to 1 over 2 n squared plus n minus 2. So we were able to show that the general term of the pattern is Tn equal to 1 over 2 n squared plus n minus 2. This is easy, guys. So easy. Now, the next question, determine the value of t75 minus t74. Guys, this is so easy because now we already know our general term that it's tn equal to 1 over 2 n squared plus n minus 2. Then after that, what do we do, guys? We are saying determine t75 minus t74. This is easy, guys. Why? Because we know that t75 will be equal to 1 over 2 75 squared plus 75 minus 2, which is equal to, then what is t74? So in other words, you must first determine the values of t75 and t74. That will be 1 over 2 74 squared plus 74 minus 2. Then you get what? Guys, let's use our calculators. Please type your answer on the comment section. Please, let's use our calculators, guys. So 1 over 2 multiplied by 75 squared plus 75 minus 2. I got 2,885, 5. Now let's use 74 there. Guys, you can see that I'm also working it out using my own calculator. Guys, please use your calculators. Please, please, I beg. Then we have our answer to be equal to 2,810. I stand to be corrected with your answer, guys. I want to hear your answer as well so that it can be nice and interactive. So we have our two answers. So we were asked to determine T75 minus T74. Then what was our T75? It's 2,885, 5 minus 2,810. Then using your calculator, what will be the answer? So it's going to be 2,885, 5 minus that answer. Then we got equal to 151 over 2. Then you get your 2 marks. This was just easy. So everyone already, you have your 7 marks for the test. You have your 7 marks for the test already. Okay, so don't worry about anything. 7 marks is guaranteed for you. Okay, now let's move on to the question number 2 now. I hope we are cruising together. Question number 2. So on question number 2, guys, let's read it together. Let's move to question number 2. Given the linear pattern, wow, this is boring already because now we already know the answer. We have done this. Guys, please, if you don't understand the basics of this information we are doing now, please check out the videos I streamed the last 3 or 4 times, which I was explaining the number patterns in depth. Please look at them and look at the tutorials which you did. In the WhatsApp group, there is a tutorial which I also posted on these number patterns. Practice more and more and more so that when you're going to your test, you just go straight and get your A. Instead, let's focus on question 2. On 2.1, given the linear pattern 3 is to 7 is to 11. Let's write it down. So we are given 3 is to 7 is to 11, which is a linear pattern. What do we know about a linear pattern? That's the first question which you are supposed to ask yourself before you even answer any question. So we know that a linear pattern has the first constant difference, which is illustrated by the letter D. And how do we find the constant first difference? We say T2 minus T1 is equal to D. Or we can say T3 minus T2, or we can say T4 minus T3, or determine the value of D. So that's how you can be able to see that this is a linear pattern. This is already 2.1, determine T20. Guys, these are free marks. So there's no need for you not to get a distinction in maths this year because everything has been made easy for you by Yebo Tutor. So let's go. 7 minus 3, that's 4. Ways up. Then 11 minus 7, that's 4. Then we need T20. How do we find T20? We must first know our general formula. So in this instance, they didn't ask, what is your general formula? They just said determine T20. So what are you supposed to do in this instance? Please first determine the general formula, the general term, so that you can know the values fast on your own. So we know that since it's a linear pattern, Tn is equal to A plus n minus 1 times D. What is our value of a? Our value of a is 3 plus n minus 1 multiplied by d, which is in this instance 4. Then 3 plus 4n minus 4, then which is equal to 4n minus 1. This is our Tn. But what are we asked in the question? We're asked T20. So T20 will be equal to 4 times 20 minus 1. 4 times 20, guys. 4 times 20, that's easy because you know that 4, 8, 16. Until you multiply it 20 times, then that's 80. 80 minus 1, then you get 79. So our T20 will be 79. This was easy, guys. Easy like eating a cake on your birthday. Guys, comment. I need someone to say something. Please say something, guys. Please say something so that we can interact together. Okay. Now, moving forward. Let's move forward, guys. On question number 2.2. Now, calculate the sum of the first 20 terms. This is easy. We know that this is a linear pattern, so the sum is given. The equation Sn is equal to n over 2a plus n minus 1 multiplied by d. Okay, what is n? We say the sum of the first 20, so it's going to be 20 divided by 2, then 2 multiplied by a, which is 3, plus 20 minus 1 times 4, which is our d. Come on, guys. There's no need for you to fail maths. Then you use your calculator after that. 20 divided by 2 is 10. 2 times 3, it's 6, plus 19 times 4. Then you use our calculator, then we get 820. That will be our answer. Any question, guys? Any question? I can't see any question. So since there's no question, which means we should proceed. Question number 3. We already have 5 plus 7. We already have 12 out of 50, guys. We are cruising. Okay, question number 3. The nth term of the geometric series is Tn equal to x plus 1, n minus 1. Determine the common ratio in the terms of x in its simplest form. Guys, this is easy, guys. How do we determine the common ratio of a geometric series? We know that it's T2 divided by T1. What is T1? We are given Tn is equal to x plus 1, n minus 1. T1 will be x plus 1, 1 minus 1, which is equal to x, because this is going to be 0, then anything to the power 0 is equal to 1. So it's x times 1. T2 will be equal to x plus 1, 2 minus 1. So end up having x plus 1. Okay. What is the common ratio? We know that r is equal to T2 divided by T1, which is equal to x plus 1 divided by x. Then we cancel this, then we are left with our r, which is equal to x plus 1. Yo, this is so easy, guys. This is so easy. I hope you are also seeing that this question is so easy. It's also straightforward. Okay, now let's proceed, guys. Let's proceed. Let's proceed, because we're gonna have much time spent when we are doing our what do we call this, our Euclidean geometry. So let's rush as much as we can for now. Okay, now let's proceed, guys, to the next question. So on the next question, determine the values of x so that the series converges. This is easy, guys. We know that this is 3.2, right? We know that the series converge if r is between -1 and 1. What is our r? Our r, we have already calculated, it's x plus 1. Then we solve for x now. So it's going to be -1 minus 1 less than x less than 1 minus 1. Okay, then it's -2 less than x less than 0. So this is the convergence of this geometry. This is easy, guys, because we have already done this and now we're just summarizing fast. Calculate the sum to infinity. Wow, they must take us serious. 3.3. calculate the sum to infinity. They must take us serious because we know the equation sum to infinity is equal to a over 1 minus r. What is our a? Our a is the first term, and in this instance, our first term was x. 1 minus, what is our r? Our r is x plus 1. Wow, guys, this is so nice. X over 1 minus x minus 1. Then 1 minus 1 is 0. So it's x over negative x, which is equal to negative 1. So this is the sum to infinity. This is the sum to infinity. If x is equal to 1, write down the first three terms. Wow, guys. Now we are just substituting to what we already know. This is so easy, guys. So substituting 1 there for x, we're gonna have the first term to be this is 3.4. This is easy, guys. So it's gonna be initially we're given tn to be equal to x, x plus 1 n minus 1. Okay, so they said if x is equal to 1, which means this is 1 plus 1 n minus 1. Okay, so it's gonna be 2 to the power n minus 1. So this is our tn in general. What is our t1? T1 will be equal to 2 1 minus 1, which is equal to 1. Sorry, guys, because 1 minus 1 is equal to 0. So it's 2 to the power 0 is 1. Then t2 is equal to 2 minus 1. Then we have 2. T3 will be equal to 2 3 minus 1, which is equal to 2 to the power 2, which is equal to 4. Just like that, guys. So the first three terms will be 1 plus 2 plus 4, because they said for this series. So you can't write it in a sequence form. So you have to say 1 plus 2 plus 4. Now on 3.5, determine the sum of the first 25 terms of the series. Calculate. This is so easy. The sum of which sequence? This for which series? This is a geometric series, and we know that Sn is equal to a Rn minus 1 over R minus 1. Guys, this is so nice. This is so nice. There's no need for you to fail, guys. What is our A? Our A is 1. We are determining the sum of the first 25. So 1. Then it's going to be, what is our R? Our R is always T2 divided by T1. So it's going to be 2 divided by 1, which is equal to 2. So it's going to be 2 to the power 25 minus 1 over 2 minus. Wow. Then after that, we use our Casio calculator. You can never go wrong with this calculator. So it's going to be 2 to the power 25 minus 1 divided by 2 minus 1. Then I get this long answer, guys, using my calculator. So you just write it down as it is. So the answer is 5 4 4 3 1. So let me try to count it. So it's gonna be 33,554,431. Wow, I was able to count that number. So that's the answer. So what do you do in this instance? You just apply, just listen to the question, guys. What does the question want? Then after that, you are free to go. Euclidean geometry is the next section now, because now we are going to question number 4. So just to summarize, do a small fast summary, guys, on our Euclid on our analytical on our number patterns. What is important, guys, is to understand that when you are solving problems in your test, you must have the mindset of everything which you've done. Put it in your mind. I've done linear patterns, I did quadratic number pattern, I did geometric sequences. What's the difference between the three? How do you see that this is a geometric? How do you see that this is a quadratic? Then after that, now we are just applying. So when you're reading, listen to the English. Show that the general formula of the above sequence is equal to this. What is this sequence? Given the linear pattern, what is a linear pattern? Ask yourself those questions before you answer anything. What is a linear pattern? So if you know what is a linear pattern, then after that, everything else is just going according to what you want. Because like now you already know, and you already know how to manipulate the information which you are given. Let's go to Euclidean geometry. Question number 4. Question number 4. Question number 4. Are you ready for this? analytical geometry. Are we all ready? Are we all ready? I'm ready. Let's go. PON. Where is PON? Okay, that's the point. PO and N. You can see it's that straight line PON. Why am I reading so slow? I want you guys to see when I'm reading. This is how you'll be able to analyze Euclidean geometry. Okay, PON is the diameter of the circle center at A. Oh, PON is the diameter of the circle centered. What do we know about a diameter and angle subtended and the circumference okay, no problem, it's fine. And we are given that O is the center, so any line which is drawn from O is going to be the radius. Okay, it's fine, it's fine, which means this is great. TM is a tangent to the circle. Wow. What do we know about a tangent? We know that we have passcode theorem. We also know that the tangent from the same point are equal. So in other words, when we try to rotate that thing, we already see that. Let me rotate it for you. Let me rotate it for you so that can be nice. No, we want to see it upside down. Want to see it upside down. Here it is. So we can see that this is our circle, but so in other words, why am I rotating this? I'm rotating this for you guys. When you're writing your exam, don't feel ashamed to rotate your question paper upside down like the way I did right now. Rotate it upside down so that you can be able to see the angles. So we are saying that TM is the tangent to the circle. So we can actually see that, oh, this is TM, and this angle, which is 66 degrees, when we hold that MN like this, it subtends on angle P. So that angle P there is going to be equal to 66 degrees. Analyzing the question. That's the most important part in Euclidean geometry. Before you give a reason, understand which theorem are you dealing with. So in this instance, we know that this is passcode theorem, and passcode theorem, that's how it's applied, and that's how you understand and answer the question. A point on a circle R. Where is R? Oh, here is R. Is another point on the circle such that OR is parallel to PM. What do we know about parallel lines? Euclidean geometry is so nice. It's so nice. What do we know about parallel lines? We know that PM is parallel to OR. What do we know about parallel lines? So in the question, they can either be alternating angles, they can either be corresponding angles. Definitely, I already say that O2 is equal to angle P because you can see there's a corresponding angles. Wow, great. They can be also co-interior angles, so angle P plus that angle O1 is equal to 180 degrees because they are co-interior. So play around with the terminology which you know. Then we are also given that angle M is 66 degrees. Wow. Calculate the following with reasons. This is great, guys. They say that the first question, what is the angle P? What is the angle P? What is the angle P? This is easy, guys. This is easy. We've already answered these questions, but okay, so that someone can see. 4.1. So angle P is equal to angle M1 is equal to 66 degrees. Why? Tan chord theorem. Theorem. The beauty of Euclidean geometry. Let's go. 4.2. What is angle M2? Where is M2? Where is M2? Where are you, M2? Guys, this is so easy because we know that PON is a diameter, which means that angle which is subtended, which is M2, is equal to 90 degrees. What's the reason? Angle in a semicircle. It's angle in a semicircle. That's 90 degrees. Where's the last question? 1 mark. 4.3. What is angle N1? Where are you, N1? Where are you? Let's look at you. Guys, here is our N1. What's the value of angle N1? This is already easy, guys. If we say that, let me remove this part so that you can see this. If we say that in triangle PMN, okay, so we can say that angle M2 plus angle P plus angle N1 is equal to 180 degrees. Why? Some angles of triangle. Which triangle are you talking about? Triangle PMN. MN. Okay, what is our angle M2? Our M2, we said, is 90 degrees. What is our angle P? It's 66 degrees plus angle N1 equal to 180 degrees. Then now we make N1 the subject of the formula. Then it's going to be 180 degrees minus 90 degrees. Let me minus 66 degrees. So we transposed everything to the other side. Then angle N1 will be equal to our ratio, guys, 180 minus 90 minus 66. Then our angle N1 is equal to 24 degrees. Just like that. Get your answers correct. Then you are happy. Happy me, happy you. You see, we are almost done. This should be the last two questions. Yes. Now let's look at question number 5. Euclidean geometry made easy for you guys. Question number 5. In the diagram, wow, triangle ABC with points D and F. Where is triangle ABC? Oh, that's the big triangle ABC. And it has points D and F on BC. Okay, we can see that D and F, they are located on line BC. And E is a point on AC, such that EF is parallel to AD. Okay, DE is parallel to AB. Guys, you must be seeing what I'm seeing. See it first. When you're saying see it. Okay, so we are saying that EF is parallel to AD. We see that AB is parallel to ED. So guys, what is important is to understand that when we are applying the prop theorem, always indicate the parallel lines which you are also using, which you were able to see this. They gave us the ratio that AE over EC is equal to 5/4. That's great. Then they gave us DF is equal to 2 centimeters. Maybe they'll ask us to calculate CF, but I don't know what they want. Let's see what do they want. Well, CF is already easy. Give reason and calculate the length of FC. Guys, as I just anticipated, this is easy. 5.1.1. How can we calculate this question? This is so easy, guys. So this is the beauty of Euclidean geometry. We should work each and every day. We should practice so that you can be able to see what's happening. So we can say in triangle, because we are looking at ACD, let's just say ACD or ADC, we can see that FC of DF is equal to EC over, let me see something first. Yeah, let me use EC over AE. Why? This is the prop theorem. Which parallel sides are we looking at? We're looking at EF parallel to AD. Then now, what is FC? That's what we want. DF is 20. EC is 4/5. Then we want FC. Then FC will be 20 times 4 divided by 5. Then that will be 16. So then therefore FC is equal to 16 centimeters. This is easy, guys. This was just straightforward. So why am I saying it's easy? Because you have already undergone and you were with us last time when we were streaming this question and we did it so well together and we were able to say that, oh, this is how you look at angles. This is how you approach the prop theorem. So that was straightforward for every one of us. Now, calculate the length of BD. Where is BD? Here is BD. How can we calculate that? So again, we should take the triangle, okay? So that it can be nice. State the triangle which you are looking at. Straight the triangle which you are focusing at. So in this instance, which triangle are we focusing on? So we can say that in triangle ABC, okay, so that you can see where is this BD coming from. So in triangle BC, we can see that CD over DB is equal to E over EA. Y also again is the prop theorem. Now let's take the parallel signs which you are focusing on. DE is parallel to AB. AB. What is CD, guys? CD is 20 plus 16. So it's going to be 36 over BD, which we want equal to CE. It's 4 over 5. That one is easy, guys. Easy, easy, easy. Okay. Someone will ask me, how do I find CD? CD is equal to 20 plus 16. Okay. Because it's the length of DF plus CF that makes CD. Then we got that 36. So we cross multiply to get BD. So BD would be equal to 36 multiplied by 5 divided by 4. Divided by 4. Then that would be 9 times 5. That's equal to 45. So that's the length E. Now evaluate, this is easy, guys. 5.2, evaluate the area of triangle ECF over area of triangle ABC. How do we do that? This is so easy because we know that it's always 1 over 2 EC times FC sine of angle C. Okay, this is according to the area rule. Okay, or divided by 1 over 2 AC times BC sine of angle C. So this and this will cancel, this and this will cancel. So we'll be left with EC over that. So that's easy. What is EC? EC is 4. Then we have FC to be 16. We divide by 9. Then we have our BC to be 81. And we have our BC to be 81. That's easy, guys. This is so easy. So how did we reach there? We are allowed, or we used our area rule. So that's how we roll every time when we are solving these kind of problems. When we are solving these kind of problems. Okay. Then after that, we are happy. Then after that, we are able to be happy, guys. Okay. So what will be the answer? BC is 81. Where? Why? Because BD is 45. 45 plus 36. That will give us 81. Okay. Then you use your calculator. Then I'm getting 4 times 16. That's 64. Then that will be 729. Then after that, you are done. You are happy. I am happy. Then everything is good at the same time. That's Euclidean geometry for you guys. So I'm gonna try to do another one, maybe try to find in Northwest what's happening. Kanye texted and also highlighted that let's also have one from Northwest. So I'm gonna work on that and find my connection so that you can get another one from Northwest. Guys, this is what I have prepared for you guys to do, like a prep for your final control test for term 1. I hope you enjoyed. Please, if you enjoyed, don't forget to drop your comments on the comment section so that we can interact, guys. We are one family. We love you all, guys. Please don't forget to forward the link to each and every friends, classmates, so that we can grow and assist each other. Don't forget to also tune in and join our WhatsApp group. Follow us on social media, TikTok, we are there, Instagram and Facebook, so that we can be able to interact together in a nice way. Don't forget that in our WhatsApp group we give people the study material to use and study with. Guys, till we meet again, I'm hoping that Friday we can have another live. We look at the question paper from Northwest. Then after that, we are well prepared for our term 1 control test. Have a great evening.